In 2.1, we're going to go through some definitions and some terminology. We're going to talk about monomials and polynomials and some other terminology. We're also going to do adding and subtracting polynomials. All right, so let's start with a monomial. A monomial can be a number, a variable, or the product of a number and a variable. So for example, 5 is a number, it's a monomial. X, just a variable by itself, is considered to be a monomial. Or it can be the product, right? Product means multiplication. So if I take numbers and variables and multiply them together, for example, 2y, that's considered to be a monomial. You can have more than one variable. We could have 4x squared y to the third, or 2b to the fourth c. These are all considered to be monomials. So if I take something that is not a number, a variable, or the product of numbers, then it's not a monomial. So for example, if I have x plus 3, that is not a monomial because the x and the 3 are added together. It's not a product. Or if I have a negative exponent, if I had 2x to the negative 3, remember that's the same thing as saying 2 over x cubed, right? We learned that in the last chapter. Well, then that's a quotient, right? That's division. I have 2 divided by x cubed. Okay, that's not a product. Anything with a square root in it, square root of x, that is not a variable or the product of variables. So those are non-examples. By the way, just to kind of compare this one over here, if I have x cubed over 2, that one's actually okay because that could be 1/2 times x cubed. Like that's a product of a number and a variable. Okay, so a monomial, a number, a variable, or the product of numbers and variables. These are non-examples over here, right? These are examples over here. Okay, what we're going to talk about next is the degree of a monomial. So to find the degree of a monomial, it's actually pretty easy. All we do is take the exponents of the variables and add them together. So 5 I'll come back to, but x only has one variable, and it's to the x to the first power. So we would say, put over here, we're going to find the degree of each of these. We would say it's degree 1. If you look at 2y, that's 2y again to the first power. Now we don't include the 2, we only include the variable. So the variable is y, it's to the first power, so it's degree 1. If you have more than one variable like this next one, I have 4x squared y cubed. Again, I only look at the variables, I don't do the 4, but it's x squared y cubed. I add those up, 2 plus 3, that would be degree 5. The next one is 2b to the fourth c, so it's b to the fourth, c to the first. So again, I add up the powers, 4 plus 1, so it would also be degree 5. On this last example, it's only got one variable, right? The only variable is x, so it's x to the third, so I'd say it's degree 3. Okay, so to find the degree, you take the powers of the variables, the exponents of the variables, and you add them together to find the degree. All right. Let's move on. Let's do this right. Just really quick. Here's some more examples. We'll do this really fast. Again, ignore the 5. It's not a variable. Look at the x. It's to the power of 2, so this would be degree 2. Ignore the negative 1/2, but we have x to the first, y to the third. If I add those together, it's degree 4. It's 8x cubed, y cubed. Again, I ignore the 8, but I have x cubed, y cubed. Add those together. It's degree 6. Oh, and on that last one, we never talked about 5. So in this case, I have negative 3. This is like 5. There is no variable. If there is no variable, it's degree 0. It doesn't, so degree 0. Pause the video really quick. Do these 4 problems. Just find the degree of each of those monomials. So number 1, you should have gotten degree 4. Number 2, you add those together, degree 5. Number 3, degree 1, right? Y to the first power. 4, there is no variable, so it's degree 0. Okay, moving on here. Let's talk about polynomials. So here's your next definition. Make sure you have this written down. A polynomial, right, is a monomial or the sum of monomials. So if you take two different monomials, we could do, for example, x is a monomial and 5 is a monomial, and you take the sum, x plus 5, right? Sum means addition. That is considered to be a polynomial. By the way, it does say a monomial. A monomial is a polynomial, or the sum. So if I have like y to the fifth, that's a monomial. It's also a polynomial. If you go back up here, all these examples, right? All these monomials are also polynomials. But I can also find the sum of monomials. It's also considered a polynomial. So here's another one, 2x squared plus 3x minus 2. Here's another one, 5x squared y to the fourth plus 3xy squared. Right? Each of those is a monomial. That's a monomial. That's a monomial. If I add them together, it's a polynomial. Let's do one more. You could have 3x squared plus a half x minus 7x. So let's do 7x cubed plus 15. Okay, so these are all examples of polynomials. So if you take one or more monomial, you add them together, you get a polynomial. Okay, finding the degree. You're asked to find the degree of a polynomial. It's what we do is we find the degree of each separate term. Terms are things separated by pluses or minuses. So you find the degree of each separate term, and then you take the highest degree as the degree for the whole thing. So let's do that. Let's do the degree of y to the fifth. It's only got one term. It's just a monomial, so it's degree 5. If you look at x plus 5, this term, right, it's x to the first power, it's degree 1. This is degree 0. I just take the highest one. So that polynomial would be degree 1. Okay, if you look at this next one, that term is degree 2. That term is degree 1. That term is degree 0. So I'm going to say it's degree 2. I take the highest one. Now that's a little tricky. We do not add the degrees together. You just take the highest. You do each term separate and take the highest one. Okay, this one is 5x squared y to the fourth. Now if it's a single term like this is, I just add those powers together. So this is degree 6. That's x to the first, y to the second. Add those together. It's degree 3. For the entire polynomial, though, I just take the highest one. So we'd say it's degree 6. Okay, this last one, this one's degree 2, degree 1, degree 3, degree 0. For the entire polynomial, we take the highest one. The highest one was a 3, so we'd say it's degree 3. Okay, let's talk about two more things. Let's talk about standard form. That isn't written down here, but add this to your notes. Let's talk about standard form and a leading coefficient. Standard form is when you take a polynomial and you write it term by term, and you start with the term with the highest degree and you work your way down. So let's do this example right here. If we look at it. So we start with the term with the highest degree, which is the minus 7x cubed. I'm going to put it first. Then we go down to the next one. And notice how it's a minus 7x cubed. That minus belongs to the 7, so it becomes a negative 7x cubed when it's in front. The next highest degree was this degree 2 right here. So I'm going to go to plus, it's a positive, so plus 3x squared. The next highest one was this half x, so plus a half x. And my constant is the lowest one. So if you look, it goes in descending order. The highest degree, degree 3, degree 2, degree 1, degree 0. So that's what we refer to as standard form. Sometimes you'll hear standard form is described as descending order, which means highest power, work your way down. The leading coefficient, coefficients are numbers in front of variables. So negative 7 and 3 and a half, and 15 actually isn't, sorry about that. 15 is not is a constant, it's not a coefficient. So the coefficients are the numbers in front of the variables. So the leading coefficient is the number in front of the term with the highest degree. So if you have it in standard form, it'll always be the first one. So in this case, the leading coefficient would be negative 7. And we'll do some more practice with this. Okay, so let's look at some other examples. Let's do, well, I thought I had a different one there. That's okay. Let's do this one right here. So if I have 3 plus 2x cubed minus 7x. If that's my polynomial, let's put it in standard position. or standard form, excuse me, and say what the leading coefficient is. So standard form is we put the highest degree first. This is degree 3. It's got the highest power. It goes first. The minus 7x goes second. 7x to the first. And the 3 is degree 0, so it goes at the end. Okay, so now we have it in standard form. This, the number in front of the highest degree, the 2, is called the leading coefficient. Okay, next thing we're going to cover is we're going to go through some ways of classifying polynomials. So if you go to this place in your notes, we have those examples. These are all polynomials, -4, 2x minus 3, x squared minus 7, and down the line there. We're going to classify them by degree and by the number of terms. So let's do this really quick. Let's do degree first. So the -4 does not have a variable, so it's degree 0. I'll put the degree right there. But we have a name for that. Anything that's degree 0 we say is a constant. Which should kind of make sense because there is no variable. It's just a number. It never changes. It's a constant. Okay, this term is degree 1. This is degree 0. The highest one is 1. So that 2x minus 3 is degree 1. We call that a linear polynomial. If you look at this next example, the highest power, highest degree is 2. We call it quadratic. Look at this one, x squared minus 3x plus 1. The highest power is 2. So it's degree 2. So it's also a quadratic. And this last one, the highest power is a 3. Right, this one's a 1. This one's a 0. So the highest one is a 3, degree 3. So it's a cubic. So those are the names. So degree 0 is a constant, degree 1 is linear, degree 2 is quadratic, degree 3 is cubic. So that's how you can classify these or give them names according to by their degree. The other way is by the number of terms that they have. So if you look at this, this one has one term. Something with one term we refer to as a monomial. We already talked about those. Monomials have one term. There's no pluses or minuses. This one has two terms, 2x and a minus 3. So we consider that 2 terms. The prefix for 2 is bi, so it's binomial. Prefix for 1 is mon. Prefix for 2 is bi. This one's got 2 terms, x squared and 7, so it's a binomial. This one's got 3 terms. It's a trinomial. This one's got 3 terms, so it's also a trinomial. Once you get past 3 terms, we're not going to memorize names for them. You can just call it a 4-term polynomial or a 5-term polynomial. Same thing with degree. Once you get past a cubic, we're not going to know names for them. But I do want you to know these. Okay, so I need to classify them by degree and by the number of terms. The last thing we're going to do, let's do this problem right here first, though. It says write 15x minus x cubed plus 3 in standard form. Identify the degree and the leading coefficient. So standard form, we start with the highest degree, which is a -x cubed. It comes first. That's degree 3. This one is degree 1. That's degree 0. So next comes the 15x. And next comes the 3. So now it's in standard form. It says identify the degree. Well, the highest power is 3. So this is degree 3, which means we call it a cubic. It didn't ask us to do this, but it does have 3 terms. 3 terms we refer to as a trinomial. So it's a cubic trinomial. Identify the leading coefficient. That's the number out in front. If it doesn't have anything in front, it's a -1. So that -1 is the leading coefficient. All right, the next thing we're going to do is add or subtract polynomials. Get down here. So to do that, we first have to understand what like terms are. So this is in your notes there, but like terms are terms that have the same variables with the same exponents. You've seen these before. An example would be 5x plus 2x. Well, they're the same because they both have an x and they're both x to the first power. So they have the same variable and the same exponent. The reason why like terms are important is because you can add like terms together. 5x plus 2x is 7x. Or if I have, say I have 2x squared plus 3x plus 5x squared minus 8x. Okay, the like terms would be the 2x squared, right, and the 5x squared. They're both x squareds. And I can combine those. I just go 2 plus 5 is 7, so 7x squared. I also have there, right? I have the 3x and the 8x. They're both x to the first power, so I can combine those. So I'm going to go 3 minus 8. 3 minus 8 is a negative 5, so minus 5x. Okay, so there is, I combine my like terms. That's simplified as far as I can go. Let me give you one to try. If you have 3x to the fourth plus 5 minus 8x to the fourth plus 2x minus 7. Take that problem right there. I want you to identify the like terms and then combine them together. So pause the video and do that, and then you can check your answer. Okay, so the like terms would be the 3x to the fourth minus 8x to the fourth. Make sure the sign goes with it. So I go 3 minus 8. That's negative 5x to the fourth. I'm going to do it in descending order. I'm going to do it in standard form. So the next thing would be this 2x. Well, the 2x isn't like terms with anything. There's nothing else there that has an x to the first power. So it's going to be a plus 2x. And then I have those constants. I have the minus 5, or the plus 5, sorry, and the minus 7. 5 minus 7 is a negative 2. Okay, I've combined all the like terms. So once you know how to combine like terms, it's really easy to add or subtract. Let's go through this example A right here. I'm going to do this one if you just want to watch. So the first thing I'm going to do is just write them without the parentheses. So I have 2x cubed minus 5x squared plus x plus 2x squared plus x cubed minus 1. Once you have them written without the parentheses, we're just combining like terms. So I've got the 2x cubed, and this is a 1x cubed. They're like terms. So we have those together. 2 plus 1 is 3. I have the minus 5x squared plus 2x squared. Minus 5 plus 2 is a minus 3. The x squared stays the same. When you combine like terms, you never change the variable or the exponent. I've got this plus x. There's no other x's there. It's just going to stay the same. And I've got that minus 1. There's nothing like terms with it, so it would just stay minus 1. Do this example B with me. Let's do a different color. So again, write it without the parentheses. 3x squared plus x minus 6 plus, and nothing changes in that second one. It's just plus x squared plus 4x plus 10. Okay, combine like terms. I've got 3x squared plus 1x squared would be 4x squared. I've got a plus x plus 4x. Add those together. So that's a 1 plus a 4. Notice how the x stays the same. Just 1 plus 4 is 5, and it's still an x. And I've got the minus 6 plus 10, minus 6 plus 10, the plus 4. I combine all the like terms. I'm done. There's my answer. When we write our answer, usually we'll write it in standard form. I start with the highest power, the highest degree, 2, 1, 0. I just work my way down. Okay, I want you guys to try one on your own. Actually, this one's a minus. Let's do this one together, and then I'll have you try that last one on your own. Okay, so minus is just a little bit different, and here's why. So I'm going to write it without the parentheses. I have 4n squared plus 5. Now, when I have a minus, I'm subtracting everything inside of those parentheses. So I have to minus a negative 2n squared. Well, if I minus a negative, that changes to a plus. But I also have to minus the 2n. It was a positive, so now it becomes a minus 2n. And I also have to minus that minus 4. If I minus a minus 4, it changes to plus 4. So if you look what happened there, that minus carried through to everything. That changes all of the signs. That's probably the biggest error we make, is we forget to carry the minus through to each separate term. Okay, let's combine like terms now. The 4n squared plus 2n squared, 4 plus 2 is 6. It stays n squared. I'm going to do the n next. There are no other n's, so minus 2n. But I do have the plus 5 and the plus 4. Add those together and end up with plus 9. I want you guys to try B. This is our last example. Try this on your own, so pause the video, try it, and then come back and I'll run through it with you. Okay, so write it without the parentheses. I have 4x squared minus 3x plus 5. This one has a minus. It's got to carry through. So it's minus 3x squared It's minus a negative x, so plus x, and it's minus a negative 8, so plus 8. So you've got to make sure as you carry that minus through that it changes all the signs. The 3x squared becomes a minus, that becomes a plus, that becomes a plus. Okay, now we're just combining like terms. The 4x squared minus 3x squared, they're like terms. 4 minus 3 is 1, so it's 1x squared, or x squared. I have a minus 3x and a plus 1x. Minus 3 plus 1, minus 2x. You've got a plus 5 and a plus 8, plus 13. Okay, you've combined like terms. Nothing left to do there. We've got it in standard form, and we're good. So the adding and subtracting is pretty easy. Most of it's just combining the like terms. Just be careful with the minus. Okay, if you're subtracting the polynomial, you have those parentheses. You've got to carry that minus all the way through before you combine like terms. All right, good luck.